Good afternoon. Myself is Dr. Sukumar from Textile Engineering Department, K.S.R. College of Technology. Today class, let me explain about the shedding mechanism on the weaving. The shedding mechanism consists of three main operations. That is rising of the warp sheet, and by that way the shuttle will be traveling to the left side to the right side, or right side to the left side of the weaving machine. If you see here, what is meant by actually the shedding mechanism? The shedding is the process of rising and lowering of warp yarn by the harness to make the opening of the filling, that is called a weft yarn, to pass through it. In last class, just we have seen about the main primary motions. The primary motions are shedding, picking, and beater. That is simple to understand is that we remember that our old singer called SVP Balasubramaniam. So S stands for shedding. P stands for picking, and next is that beater mechanism. So let us class today starts with the shedding mechanism. That is that the main objective of the shedding is that to divide the warp threads into two warp sheets. And normally the warp sheets will be in one form, one sheet. So we have to divide it into two sheets. That is the top layer and the bottom layer. Then the top layer is called the top sheet, and the bottom layer is called the bottom sheet. The rise and lower form the warp yarn is called as shed. And if you see here the types of shedding mechanism, the shedding mechanism normally divides into three types. One is tapered shedding mechanism, the Dobby shedding mechanism, and the jacquard shedding mechanism. Actually, if you see here, the tapered shedding mechanism is a mechanism where in power looms, in the Dobby and all this mechanism, just we use it Dobby mechanism also. In power looms also. And if you see here, the tapered shedding mechanism is able to control up to only 8 to 12 heel shaft. More than that, then we have to go for a Dobby shedding mechanism. Then if the design is larger than this, the 24 heel shaft, then we have to go for jacquard mechanism. If you see here, the tapered and Dobby shedding mechanisms control the heel frames. That is, heel frame is called the heel shafts, and the individual warp threads are controlled with the help of jacquard mechanisms. And if you see here, in characteristics of the shedding mechanism, the characteristics just we can as I have told that the shedding mechanism can be able to control different number of heel shafts. If you see here, the harness here, what I mean the harness is that number of heel shafts. Here in CAM system, it is able to control up to 12 heel shafts, and in Dobby mechanisms, it is able to control up to 28 heel shafts. And in case of jacquard mechanism, it is unlimited. The maximum, the picks, number of picks can be about 1,80,000 picks can be inserted as a larger design shapes in the fabrics. And if you see here, the shedding mechanisms may be of positive or negative in actions. The positive shedding mechanism is that the heel shafts are both raised and lowered with the help of cams or the eccentric systems of shedding mechanisms. If you see here, negative shedding mechanisms, either the heel shaft is raised or either the heel shaft is lowered with the help of mechanical device, and the alternate mechanism is controlled with the help of springs. And if you see here, if you see here, the tapered shedding mechanism is used to control the tappets and to control the up and down movement of the shafts. The tappet is given in a rotatory motion, and so that it depresses the follower. This we call, I will show the figure, follower and a lever known as respective of anti-friction bowl and threadle arrangement by means of which the heel shaft is operated. The bulkiness is it's a main disadvantages in case of the tapered mechanism, so that because of its bulkiness, just the number of heel shafts which we able to control, which we can number of heel shaft we cannot maximize the number of heel shaft because of its bulkiness. The bulkiness of the mechanical movements limits the loop to control up to 8 heel shaft, and more than 8, then we have to go for an alternate mechanism. Therefore, the tapered shedding is simplest and least versatile shedding mechanism. Any design more than 8 heel shafts requires a Dobby heel mechanism. And this is the negative tapered shedding mechanism. As I told that the negative mechanism is that the either rising of heel shaft or lowering of the heel shaft is done mechanically. The other other mechanism, either lowering or either lifting of the heel shaft is done with the help of springs or by another alternate mechanisms. And if you see here, this is the part where the heel shaft open the warp thread so that the settle can pass over that. The top we can see that P is an anti-friction bowl which gives an up and down movement for the heel shafts. And bottom, if you can see that the threaded lever and the anti-friction bowl, so that the anti-friction bowl it is in contact with the tappet. This tappet, so we call this tappet loop. So this tappet is operated based on the bottom shaft. If you see here in bottom shaft, one rotation of bottom shaft, two rotation of the crankshaft rotations. That is two rotation of crankshaft mechanism is that the shuttle will travel from one side, for example, if the shuttle is traveling from left side to the right side, again the shuttle will return back to the left side. That is, two operation of cycles will be completed by the rotation of one back shaft rotations. And this is the mechanism how it will be looks like in the weaving machine. Just we can see that this is the tappet lever at the bottom and anti-friction bowl, and we can see that the tappets both are fixed at opposite. There will be two tappets, then two tappets which will be fixed on the bottom shaft, and the two tappets will be rotated in the opposite, and each tappet will control each threaded levers. And next is the positive tappet shedding mechanism. Here in this system, in this type of shedding, the heel shaft is raised or lowered with the help of tappet. That is both rising and lowering of the heel shaft, both done with the help of mechanical actions. So there is no reverse mechanism using springs or rubber band. And if you see here, this is a link mechanism. Normally, positive tappet shedding mechanism, it's used by 4-link mechanism or the 6-link mechanism. This is that for the lifting of heel shaft up or down. If you see that right side, that is left side, that you can see that as cam rotates, the tappet lever gets a motion, so that by that the heel shaft is raised or lower. Normally this positive tappet shedding mechanism will be fixed at the bottom of the loop, and negative tappet shedding will be fixed at the reversing mechanism will be fixed at the top of the loop. And next mechanism, the second mechanism is the Dobby shedding mechanism. The Dobby shedding mechanism, then when we go for a smaller more size of designs to be incorporated into the weaving fabrics, then the next mechanism is that more than the heel shaft, then the next mechanism will be the Dobby. The Dobby shedding mechanism is placed on top of the loop normally in case of power loops. In case of modernized loops, it will be fixed at the side of the loops. So to produce the figured patterns on the fabrics. And if you see that using larger number of heel shaft, then the tappet loop has the limitations. The Dobby is also known as witch or wizards. Wizards is that it fixes on some of the wall like that. So that we call that wizards. Then the Dobby control the heels using the jacks and lever and less space than the tappet shedding mechanism because of the arrangements, because of the lever arrangements. And the Dobby looms for motif development. Here we call that motif is that in textile, that motif means a small figured effect designs. And tappet loop has a limitations of 8 to 12 heel shaft. Then 12 itself, there will be more operations on the warp yarns. Then more operations, more strain is given for the warp threads. So here we go for an advanced mechanism of next to tappet mechanism is that Dobby mechanisms. Then if this is normally used for decorating designs in woven fabrics to control the loom control the loom to produce a different structured fabrics. And normally if you see here the difficulties in Dobby mechanisms are more complicated. There is a possibility that more faulty fabrics can be produced on this Dobby mechanism, that is mainly on mechanical Dobby mechanism. Due to complexity, more liable to produce a faulty fabrics than the cam systems. And Dobby mechanism is higher initial and maintenance cost. That is that separate it's a separate device which is fixed on the weaving machine. And if you see the scope of the Dobby, limited between tappet and jacquard. It is limited between tappet and the design is limited between tappet and the jacquard. The number of heel shafts can be actually controlled with the Dobby is about 40. This is theoretical calculations because of the pitch. Pitch means the distance between the each field shaft, that pitch. Theoretically, we can able to control up to 48, but practically, in case of woolen and worsted fabrics, then we can able to control up to 36. In case of cotton and allied fabrics, then we can able to control up to 24 kill shaft. This is the normally which we do that. And in classification of Dobby mechanisms, then normally the Dobby is classified again into 3 types. One is negative mechanism, positive mechanism, and rotary mechanism. Negative mechanism is, as I told that, the may be either rising or lowering with the help of mechanical device. And in case of positive mechanism, the rising of kill shaft and lowering of the kill shaft both simultaneously done with the help of the mechanism. Then next is that rotary Dobby mechanism. It is somewhat different mechanism in which by the way of rotatory motion given on the Dobby device, it able to control the kill shaft rising and lowering. And this can be also again classified into mechanical and electronic type. The first wooden type of wooden lamp Dobby was made commercially in 1898. Then if you see here the pecking for the Dobby designs, for example, this was the pecking for designs. I think you have studied about this designs in fabric structure, and here I put a simple structure to simple to understand. 3 up, 3 down, 1 up, 1 down, 12 structure, and totally just so that the combination will be structure of 8 war threads and 8 picks for producing one complete repeat size. And if you see here, normally the wooden lattice consists of 2 rows. Each row consists of 10 holes. In the 10 holes, just we will pick using a wooden picks. So the wooden picks will be picked according to the weave designs, peak designs. So here also it is again classified into 2 different types. That is next. It is classified into 2 different types. One is left hand Dobby and right hand Dobby. Before going to this mechanism, I will explain what is meant by left hand Dobby mechanism and right hand mechanism. If the starting handle is at the right side of the loom, then it is called right hand Dobby. Then right hand Dobby means the Dobby is placed at the opposite to that of starting handle. The Dobby will be on the left hand side of the machine. Then if it is of back design. Then if you see here, if you see here, it is right hand Dobby means the starting handle will be on the right side, and left hand side means that the starting handle will be on the left side, and the Dobby is placed. The Dobby mechanism is placed on the right side. This is the concept, and this is the pecking arrangement, because the pecking arrangement is different for right hand Dobby and left hand Dobby. For right hand Dobby, just we will do from right side to the left side, and left hand Dobby just we will do from the bottom to left side to the right side. This is the common difference. And next, if you see here the feeler for the Dobby mechanism, just in last figure, just we have seen that how the feeler for the Dobby, the pecking arrangement. So that here the feeler for the Dobby mechanism, as the drum rotate, the pattern drum, that is the pattern drum on which the wooden lattice will be placed, and based on the wooden lattice rotation, the feeler will be movement. One is longer feeler and another is shorter feeler. One longer feeler will be hooked and another shorter feeler will be without hook. That is the concept, that it will control the alternate arrangement of the rising of first heel shaft and the second heel shaft. If you see that the shedding mechanism for the Dobby, it can be classified into 2 different types. One is of closed shed, other is again open shed. Again, it is classified into different types that we will study when we study about the jacquard mechanism in detail. Here, the general concept is that it is mainly classified into 2 different types. One is closed shed and second is of open shed. Here, in case of open shed, closed shed, after completion of the shed formation, it returns back to its original, the center position of the loom. That warp sheet is closed to the normal. That is called the closed shed. The open shed is that the minimum movement is given for the warp sheet. That is, minimum abrasion is given for the warp threads. So that when the shed is open, sometimes the same shed has to be formed, same heel shaft has to be lifted for one pick or maybe at the second pick also. So for that case, that particular heel shaft will not be lowered down. So that in that case, that we call as open shed mechanism. That open shed mechanism can be lead to higher speed because the heel shaft is not written to the closing sheet formation. So it will be in the form of the same segment of the lower or in the upper, forming the upper shed formation. So the advantage is higher speed and breakage is reduced because of unnecessary movement of the heel shaft. The abrasion between the warp threads are reduced. And if you see here, the Dobby mechanism, it is of single lift Dobby, and single lift Dobbies now it is totally eliminated. It is not used. All systems eliminate performs their functions once every weaving cycles to open a shed, and then they can return to the original position before the new cycle. So for this reason only, before the slide just I explained about what is meant by open shed and the closed shed. The shed is closed every weft insertion. That is every one operation, and pick is beaten up at the closed shed. And advantages is that is mainly used in case of woolen and worsted type of fabrics. The speed is limited to the 160-180 RPM. Next is the double lift Dobby mechanism. That is the double lift mechanism. It's all new type of Dobbies are double lift mechanisms. Its cycles occupies about 2 picks. One cycle of rotation occupies about 2 picks. That is one shedding, one picking and one beaten. Again one shedding, one picking and beaten. That is 2 cycle of operations. The system elements operate once every 2 weaving cycle, but the shed opening is achieved by every pick. The most of the motion is the Dobby occur at off time loom speed. The open shed is produced, unnecessary waste, unwasted movements are eliminated and suitable for high speed weaving operations. And negative shedding mechanism. In negative shedding mechanism, the heel shafts are lifted by Dobby or lowered by the spring actions. The single lift Dobbies which have become absolute. As I told that the single lift Dobbies are absolute. Now mostly now the Dobbies are with that of double lift mechanisms. All modern negative Dobby mechanisms are double lift Dobbies. Negative Dobbies tend to have simpler than positive Dobby mechanisms. Next. This is the thing, the image just we can see about the negative Dobby mechanisms. We can see that at the bottom the return action of the heel shaft is taken with the help of springs and the lifting action with the help of jack levers. And this is the complete view structure of the negative Dobby mechanisms. The structure based on that, before slide just I explained the pecking mechanisms, and the wooden pegs lattice are placed on the pattern wheel, and by the mechanism of feelers that particular hook is sensed, then particular knife is jack is operated, then particular heel shaft is raised or lowered. And this is the complete view structure of the climax Dobby. Then if you see here, actually this diagram explains about how the mechanism on the weaving machine. The 2 jack levers, inside jack lever and outside jack lever, which is connected at the buckle lever, and this buckle lever is controlled with the help of S lever, and then this S lever is connected with the upper hook, and one is upper hook and second is with the lower hook. So only I told in case of the feeler mechanisms, the longer feeler and the shorter feeler. The longer feeler will contact with that of outside, that is outer jack lever controlling, and inner jack lever will control the shorter, the feeler mechanisms. And then for example, nowadays the card cutting machines are nowadays used. This type of card cutting machines are mainly used to control the wooden lattice. Now it is converted into a paper patterns. Now the Dobbies comes with a paper patterns. Thick plastic forms of pattern sheets are used, and the designs we can integrate it into this machine, and it automatically cuts this paper plates, and this paper plates can be directly loaded on the pattern rotatory type of Dobbies. And this is a smaller type of Dobby mechanisms where the picking has been done on the cord directly on the smaller designs. This can be used on the smaller type of Dobby mechanisms. And if you see, consider that hard mechanism and wooden lax mechanisms, then if you see here, the time required for the making of pattern is about 1.1 hour. Here, in case of pattern making, it is about 0.5 hour, 30 minutes. Next is of electronic Dobby mechanisms. In case of electronic Dobby mechanisms, the modern dobbies utilizes electronic systems for input of heel frames, lifting and lowering of the patterns. Here, instead of pattern cards and paper cards, the electronic in the form of soft copy, just you can load it on the machine and it can able to control up to, if you see here, 6400 picks can be stored and it can be operated. And if you see that working of electronic Dobby mechanism, it works on electromagnet mechanism. That is, the jack levers are attracted by the way of electromagnet, and by the way of electromagnet, that particular heel shaft is raised and lowered. This is the image for negative Dobby with electronic control system. Then right side of the slide, just we can see that the electromagnet and the way of the S lever. S lever is connected with the buckle lever, and buckle lever on the top it is connected with the jack, and the whole part just where we can tie with the rope to control the heel shaft rising. And this electronic Dobby is controlled. It is fitted on the side of the loom. Mainly it is used on modern looms, because this is modern looms. Normally in the modern looms, the productivity may be of one day it can able to produce about 120 to 150 meters, based on, it depends actually. Normally minimum it can able to produce per day about 120 to 150 meters. So the normal mechanical Dobby, if you are fitting on that modern looms at higher speed, there is a possibility that the Dobby can burst up because of its high speed motions. So in such cases, just we go for electronic mechanisms. Okay, thank you for all.